This training program perspective is IBM WebSphere MQ administration. Initially we start our discussion on version 7.0. After that we discuss 7.1 features. After that we discuss 7.5 features, and we provide some document about 8.0 also. Okay. Here MQ stands for message queuing. It is a framework defined by IBM WebSphere MQ.
Can I interrupt you if I have a question, or should I wait?
Yes, please.
Like we have MQ8 now, so what is the rationale behind going to 7.0, 7.1 and 7.1?
Yeah, in WebSphere 8.0, in WebSphere MQ in 8.0, they newly introduced publish subscribe. Okay. Earlier it is publish subscribe is available, but it associated with MB. Recently completely they pushed it to MQ, publish subscribe. And some new features they enable on security. Okay. Like channel authentication records they modified. Okay, all those features we discuss.
No, my question is there any particular factor or reason that you chose to discuss 7.0, 7.1 and 7.5?
Yes, we are going to introduce all the new features. If you take 7.0.1.0, from that version it supports multiple MQ installations. Okay, and a host. Maximum we can install 128 MQs per a host.
So can I assume,
Can
I assume that these are the most commonly used versions at the moment? I don't know anything about this, so my question here is the reason why we have chosen.
Yeah, Murali, can you speak close to the mic? It's not clear.
Can you hear me now?
Yes, please.
Yeah. So I do not know what are the MQ versions, etc. So since you chose 7.0, 7.1, 7.5 and you said 8.0 is there, my question here is, you chose this version maybe because these are the most commonly used versions at the moment. Is that the case?
Yes. In most of the current places they are using 7.1. Some servers they are migrating 7.1 to 7.5. So they not yet migrated to 8.0. Okay. So in the following year, clients may migrate from 7.1 to 8 or 7.5 to 8. Okay. In every version, the messaging mechanisms are same. Okay. But new features they introduced about security, about multiple installations, about multi-instance, and about publish subscribe. Okay. All those features we discussed.
So from 7.0 to 8, we have only 0.1, 0.5, or are there any other versions?
If you take 7.0, only one MQ we can install. Only one MQ per host we can install. Okay. After that, they introduced 7.0.1.6. From this version, that means this is the maintenance level. If you apply this maintenance level on 7.0, it supports multiple MQ installations. Maximum we can install 128 MQ instances per host. Okay. If you take 7.0.1.0, they newly introduced multi-instance queue manager to enable high availability. Okay. Multi-instance queue manager. They introduced this feature. It supports high availability. Okay, they are going to run 2 instances. Then one as active, one as passive. When active instance fails, standby instance becomes active. Okay, this is how they are going to provide the high availability by configuring multi-instance. This feature is available with 7.0.1.0. If you come to 7.1, they newly introduced channel authentication records. Okay. From that 7.1 itself, they introduced telemetry After that, they added more features to that telemetry. In 8.0, they completely pushed the publish subscribe to MQ. Okay, this is how we are going to discuss all. Client reconnect, it supports. Okay, but messaging mechanisms are same. In 7.0 or in 6.0, the mechanisms are same, like DQM, MQ client and server, clustering, multi-hopping. The messaging mechanisms are similar in all the versions here. Okay. Yes, please. Shall I go ahead?
Yes, please.
Any queries, please? Yes, Murali.
Yeah, please go ahead. Can you hear me?
Yes, please.
Yeah, please go ahead. No more questions.
Okay. IBM WebSphere MQ is an IBM middleware message transport product. It enables distributed applications to communicate each other by exchanging data in the form of messages. IBM MQ built on Java. It is platform independent. It supports 80 plus platforms. It is available on a large number of platforms like Windows MQ, Unix MQ, AS400 MQ, mainframes MQ. Like this, it supports 80 plus platforms. Okay. Here MQ stands for message queuing, message or messaging, anything is fine. MQ stands for message queuing or messaging and queuing. This is the framework. What is messaging? Messaging is the mechanism to define data as a message to exchange over the network. Queuing is the mechanism to hold data until processed by the remote service. See here, IBM WebSphere MQ, known as an integration engine, it integrates distributed applications irrespective of the programming language, platform and protocol by providing an interface MQ API. Okay, see here, yeah, Jagan, here I hosted Windows host and Linux host. On these two distributed systems, applications are distributed. Applications are distributed. This is my business service. Name of the application is business service. Here name of the application is business operation. This business service might implemented in C language. It might implemented in Java, .NET or in C++. Whatever the programming language. Business operation might implemented in C or in C++ or in Java or in .NET. In between these two distributed applications, we wish to enable reliable communication. To enable reliable communication, here we introduce message-oriented middleware. It is IBM WebSphere MQ. IBM WebSphere MQ. Here this IBM WebSphere MQ integrates distributed applications irrespective of the programming language, platform and protocol by providing an interface MQ API. Programmers need to know implementation of MQ API. Then programs can define their data as message. They can put and get data in MQ server. See here, MQ API. Programmers are going to implement this API. Then programs can define data as a message. Here my business service wants to send data to business operation. First, business service defines its data as a message. Message is collection of data. MQ message consists two parts morally. Okay, they are MQMD header and payload. Payload known as message body. Here application defines actual business data. Application here may insert XML data, text data, binary data, non-XML data, whatever the data it can define in message body. MQMD header holds control data about the message. Control data is nothing but what is the message ID, what is the message correlation ID, what is the message expiry, what is the message priority, what is the message expiry, what is the message persistence, this kind of data. Okay, who defines this message? An application. The MQ server does not define any message. It does not define any data on message. Now my MQ service, my business service connects MQ server. It puts data in queue. It puts data in queue. Queue is an object in MQ series. Queue is a file, data structure and container. It holds data until processed by the remote service. Queue is the only resource in MQ server to hold data. Data has come to the server as message. That message gets stored into queue. Remote service available. Now it connects MQ server. It gets data from queue. On MQ server, major operations are put and get, write and read. An application writes data, an application reads data. Here remote service requested the data from queue, so queue forwards. Here MQ server supports once and only once delivery, guaranteed delivery. See, do you know the passbook? You know very well. Jagan, Murali and Vijay. Bank passbook. In bank passbook, we can see the entries like debit and credit, right? If we deposit, they credit. If we withdraw, they debit, right? These two kind of transactions we can see in the passbook. Here also the same. Here we can see put and get. No other operations. Just here it can route the data. MQ server acts as a bridge between distributed applications to exchange data in the form of messages. It does not perform any operations on the message. Are you clear here?
Yes, yes.
It is just like a passbook. One application writes data, one application reads data. For suppose if we deposit the money, they credit on our account. If we withdraw money, they debit on our account. Once if you withdraw money no more, right, in your account. Here also the same. When remote service draw the data from the MQ server, the data no more. Why? MQ server supports once and only once delivery and guaranteed delivery. It does not support duplication delivery. Here it enables reliable communication between distributed applications by integrating them irrespective of the programming language, platform and protocol. Any application can communicate with any application through MQ server. Okay?
Okay.
Here we can say IBM WebSphere MQ, known as store and forward mechanism. Bundle of data comes to MQ server. That data gets stored into object queue. When remote service requests the data, it forwards. Just it is store and forward mechanism. Okay?
Okay.
Good. Now let me show you just PPT. In between distributed applications, MQ server can enable one-way communication and two-way communication. It is possible. Look at here. Just business service defines its data as a message with the help of MQ API, and it connects MQ server. It puts data in object queue. Queue is a file. Now remote service requested the data. Queue forwards. The data no more, right? Just it is store and forward mechanism. It acts as a bridge by integrating all the distributed applications to enable the communication. Here programs communicate by putting messages on queues. Here application A puts message on Q1 for application B. Application B available on MQ server. Now it's getting the data. Here you can see clearly application A has sent pink color message to Q1, right? Application B retrieved the pink color message, no more in Q1. Okay. Why? Because MQ server supports once and only once delivery and guaranteed delivery. Here it is one-way communication. Here we enable two-way communication, right? Application is sending data for application B through Q1, it's receiving data through Q2. Application A putting data on Q1, getting data on Q2. Application B getting data on Q1, putting data on Q2 for application A. This is request and reply messaging model. When we implement request and reply messaging model, we are going to configure, we are going to enable this kind of communication. MQ supports MQ can enable time independent communication between distributed applications. Here application is putting message in Q1 for application B. Application B not available now. Okay. When it becomes active, it connects MQ server, it draws the data from the MQ server. Okay. No constraints on application structure. You can enable one-to-one communication, one-to-many communication, many-to-one communication, many-to-many communication. Any kind of communication it supports. No constraints on application structure. See, as you know, MQ message consists two parts, right? MQMD header and payload. Message body may contain XML data, it may contain text data, it may contain binary data, it may contain anything. Whatever the data application defines in the message body, that message holds. Okay. Then that message comes to the MQ server, queue is going to hold. When remote service requests the data, it forwards. Okay. What IBM says about MQ once and only once delivery and guaranteed delivery. Here you can see sample MQ message. This is message descriptor, right? That means MQMD header. From here to here. At last you can see the message body. In this message body, application has defined text data. Your application may insert binary data. Whatever the data it can insert. Sometimes he knows very well, Jagan, yeah. Sometimes we have to move the Java serialized objects from one JVM to another JVM, right?
Yes, yes.
Yes, the application may insert that kind of Java serialized objects data in message body. They can exchange through the messages.
Yeah.
Here if you observe, here you can see message type, message persistence, message expiry, message ID, message priority, which application defined this message, at what time application defined this message, on which date application defined the message. This kind of metadata, control data, MQMD header holds. Who defines the message? An application. Okay, who will consume the message? An application. What MQ server can does? It can store temporarily, it can forward. Okay. As you know, Java is an object, right?
Yes.
Everything we define as an object in Java. Before that, before go to the discussion, let me introduce this one. If you compare IBM MQ server with the DB engine, easy to understand. Anybody knows application servers like WebLogic, WebSphere application server, JBoss? You might know all these things, no problem. Any server instance is a resource manager. If you take WebSphere application server, it is a server instance, right? It acts as a resource manager. Its resources are containers, EJB container, web container. Containers are resources of WebSphere application server. Okay. If you take the DB engine is a resource manager. It manages resources. They are tables. Applications will insert the data into the tables as records. The data storage is permanent. Okay. See here, Jagan, this is the DB engine, right? Here I created tables, table 1 and table 2. In these tables, applications will insert the data as records. The data storage is permanent here. Similarly, IBM MQ server is a resource manager. It manages resources. They are queues. Queues are going to hold data in MQ server as messages. Here it is temporary storage. In database, if you create the tables, in your MQ server you create queues to hold the data. In your database, once if you insert the data, it is permanent storage. N number of times you can extract the data. But once if you withdraw, once if you draw the data from the MQ server, data no more. Here data stored as messages. See, applications putting data in MQ server as messages, queues are going to hold. In between these two resource managers, you have an application. It is J2E application. It's connected IBM WebSphere MQ server and it opened connection to DB engine also. Now it is going to update these two resource managers. How it is going to update these two resource managers means it gets the data from MQ server, it inserts the data into the database. Here we created queues to hold data. In DB engine we created tables to hold the data. In database, data stored as records, that storage is permanent. In MQ server we store the data as messages, that storage is temporary. Okay.
Okay.
Are you clear?
Yes, sir.
Good. As you know, Java is nothing but an object. IBM WebSphere MQ built on Java. In WebSphere MQ, everything we create as an object. In MQ series, predefined objects are 7. Look at here. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. These 7 are MQ predefined objects. Every object must have a name, it must be unique, right? See here, to define names to MQ objects. MQ series allowed char set is A to Z capital, A to Z small, A to Z small, 0 to 9 digits. Allowed special characters are dot, dash, mod, underscore, right? This is the only character set allowed by IBM WebSphere MQ to define names to MQ objects. There is a limitation. MQ series object names can have less than or equal to 48 characters except the channel name. Channel name can have less than or equal to 20 characters. Only for channel name, this is the limitation. Okay. What is administration? Creating MQ objects, deleting MQ objects, starting some services, stop services, suspend services, resume services, install MQ, uninstall MQ, apply the patches on WMQ base, perform the migration. These are all the comes under administration, right? So to administrate here MQ predefined objects, we are having MQ predefined commands. MQ predefined commands. MQ predefined commands are broadly divided into 3 types. They are control commands, MQSC commands, and PCF commands. As a WMQ system admin, we work with control commands and MQSC commands. We don't work with PCF commands. This is a completely programming. Programs will use PCF commands to create dynamic queues in MQ server at runtime. Here control commands we execute at OS level here. What is OS level? What is MQ server level? Later we can discuss. Control commands we can execute at OS level. MQSC commands we can execute at MQ server level. MQSC commands are only 14. Control commands are around 20 to 25. Around 20 to 25. Total MQ predefined commands are 40. Using these 40 predefined commands, we are going to administrate MQ predefined 7 objects. Okay. As you know, see here, hardware, on top of hardware, operating system, right? On this hardware unit, I install Windows. So this platform becomes Windows platform. On this Windows, we install Windows MQ. If we install MQ on Windows, it runs as a service. It runs as a service. Let me install here Windows. On top of this, I install Windows MQ. Now it runs as a service. On top of this, we host MQ objects. We host MQ objects. Yes, look at here, Murali, Queue Manager. In MQ series, Queue Manager is an initial object. Queue Manager is first and foremost object. Unless we create Queue Manager, we cannot create rest of the MQ objects. Queue Manager is a subsystem. It controls and holds all the MQ predefined objects. Queue Manager itself MQ server. Queue Manager itself MQ engine. Queue Manager is the single point of contact to all the distributed MQ applications to perform put and get operations on MQ server. See here, what I will do, I create Queue Manager. It is topmost object in MQ series. I create Queue Manager. Now, in this Queue Manager control, I can create queue or queues. I can create channel, listener, process, name list, and service. If you don't define Queue Manager, you cannot define all these objects. Okay. Here Queue Manager controls and holds all the MQ predefined objects. If an application wants to put messages in queue, application has to connect the Queue Manager. Then only it can access queue to perform either put or get. Right? Are you clear here? So what is Queue Manager? Queue Manager is an initial object. It is first and foremost object in MQ series. Unless we create Queue Manager, we cannot create rest of the MQ objects. Queue Manager is a subsystem. It controls and holds all other MQ predefined objects. Queue Manager itself MQ server and MQ engine. It is the single point of contact to all the distributed MQ applications to perform either put or get on MQ predefined queues. Okay. See here, MQ server provides MQ API, right, to communicate with MQ server. Irrespective of the programming language, IBM WebSphere MQ provides MQ API. How the programmer is going to implement MQ API, I will show you now. Look at here. He knows very well. Jagan, you are in the development, right? Yes, Jagan, are you there? Yes, Murali, can you read this?
sample C program that asynchronously puts messages to a message queue.
Yes. The C programmer is going to define one C program. Okay. In that C program, he is going to implement MQ API to make this program to define data as message and to put data in MQ server. Can you read this? Vijay, look at the screen. Can you read this?
Includes for MQ.
Yes. How IBM WebSphere MQ provided MQ API to C programming language as header file, right?
Yep.
C programmer includes this header file in his implementation. He is going to implement. See, very first application has to connect the queue manager. Can you read out this? Connect to queue manager, right, Vijay? So for that, the program is going to use MQ con call. In our MQ perspective, we say as MQ API call. In our C perspective, we say as function. In Java perspective, we say as method. Here MQ con call is used by this program to connect the queue manager. Anyhow, here application connected the queue manager. It has to open the queue. Queue is a file write. If you want to write the data into a file, you have to open the file. Here application also has to open the queue to define the data, to write the data. See here, open the target message queue for output. What is the method? What is the function? What is the call? MQ open. After that, it defines the message. It will put message in queue. Put each buffer to the message queue. MQ put right. After performing either put or get, application has to close the queue. Close the target queue. What is the call? What is the function? MQ close. If application wants to disconnect from MQ server, application executes MQ disk. See, here what happens, application connects queue manager, application opens queue, it performs either put or get. After that, it will close the queue, it disconnects from MQ server. In this sequence, MQ applications will perform operations on MQ server. Connect, open, perform either put or get, then close the queue. At the end, disconnect from MQ server. Okay. Yes, Vijay.
Yes, sir.
Are you clear?
Yep.
Now I will show you sample Java program. How a Java programmer implements MQ API. I will show you very much clearly. IBM WebSphere MQ provides MQ API as jar file to Java programming language. Java programmer keeps that jar in class path. He is going to import all the required packages to implement that MQ API. Can you read this Murali? In main method, can you read this?
Create a connection to the queue manager.
To create connection to the queue manager, Java programmer will define an object to this class. MQ queue manager, he defined an object, right? In constructor, he is going to pass the queue manager name. He is going to pass the MQ server name. Then application will connect. After that, please read this. Murali, please.
Now specify the queue that we wish to open and the open options.
Yes, here method is qmgr.access queue. Okay, method is access queue. Queue name, which queue it wishes to open, that queue name. After that, please read out this. Define a sample or define a simple WebSphere MQ message, right? They define message using some methods. After that, put the message to the queue, right? So queue.put, it puts message in queue. If application wants to get message from queue, queue.get. If application wants to close the queue, queue.close. If application wants to disconnect from MQ server, disconnect. Queue manager.disconnect, right? So here operations are connect, open, perform, either put or get, close the queue, disconnect from the MQ server. This particular coding we don't define, right? This is not our job. What is our job? Create queues in MQ server as per application requirement. Grant authorities to MQ client user IDs on MQ predefined objects to access. Perform installations, perform uninstallation, perform migration, apply the patches. Okay, configure new messaging models in your environments to enable the communication between distributed applications with the help of the 7 MQ predefined objects. Okay. So if you see the outline in MQ series, predefined objects are 7, predefined commands are around 40, major operations are put and get, data comes to MQ server as message, it gets stored into queue. When remote service requests the data, it forwards. Here data storage is temporary storage. This is the only in MQ series, right? This is very lightweight component. It is going to makes easy integrating the applications. It supports synchronous communication, asynchronous communication, any type of messaging it supports. Okay. Yes, please, any queries?
Murli here. When do we select MQ? Because there are other middleware products, right? How will I know when to select MQ?
See, not only IBM MQ, we are having many MQs. Okay, like Rabbit MQ, Sonic MQ, Active MQ, JBoss MQ. Okay, n number of MQs available. See, actually in the environments, what happens? End of the business hours, after closing their business hours, they need to update their point of sales and other business data to their centralized DB, right? So what they will do, branch offices will update the data to MQ server. So the data needs to store in a DB2 which is hosted in mainframes. So here applications will not available, source and application, destination and application will not available at the same time. Somewhere the data stage is required, staging is required. So we are going to introduce IBM WebSphere MQ. At the same time, when asynchronous communication is required, we introduce WebSphere MQ in most of the situations. Yes, please, yeah.
My question is, say there are other middleware products like TIBCO EMS. So
Yes.
when will I know when should I use MQ? And
TIBCO also access MQ only. It is also route the data, but support somewhat very much less. Nowadays, no one using TIBCO because of it is not available with new features as per the client requirements. Okay, it's somewhat difficult to integrate the applications. Some kind of development is needed. Support is very much less to the product. Okay, so no, TIBCO is replaced by MQ only nowadays. Why? Because good support to WebSphere MQ product from the IBM. Okay, at the same time, clients many are for free of cost. Only for server they are going to charge the MQ charge. They are going to charge to the only server. Okay, and it is going to easy integrating. Why? Because they provide common MQ API, right, irrespective of the programming language. The programming language is anything, just it provides an interface MQ API, then programmers can implement. Implementation also becomes very easy to the developers. Okay, if they know the basic implementation in that particular programming language, so they can implement MQ API also easily.
Okay.
Yes.
What is the difference between each MQ type, like Rabbit MQ, IBM MQ?
Types are same, messaging systems all are works the same, but IBM occupied the complete 80% of the market. So no, they are not able to giving competition. The messaging models is the same. Okay. There also we have the DQMs, client and server setups, clustering, everything, but they are not that much popular.
Why do we associate WebSphere with MQ? Is it running on a WebSphere server or something?
WebSphere, in a WebSphere application server, we are going to deploy the applications. So they are going to connect the MQ servers to communicate with other WebSphere application server. Okay.
Why do we say IBM WebSphere MQ? So is this MQ hosted within an WebSphere application server?
No. WebSphere is a family, right? It's a middleware family. It is a collection of middleware products. Okay, it is a family name. WebSphere is the name of the family. In that family, many middleware components are available. There are WebSphere application server, WebSphere MQ, WebSphere MB, WebSphere data power, WebSphere commerce server, WebSphere process server. Many middleware products available in that family. They all are from IBM.
Okay.
Okay. Each component administration is very individual. Okay. Individual administration is required on every component. So if you take a WebSphere application server, WAS admin required. If you take WebSphere MQ, MQ admin is required. If you take WebSphere MB, MB admin is required. Process server, commerce server, data power, blah 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 blah.
So how do we share notes or how do we share documentation, etc. In this online course? I'm not attending this.
They are going to give this kind of work orders. I will show you. They will share this kind of documents as work request. By looking at this network diagram, we are going to configure required messaging system, required messaging models. Have you seen this?
Very small, but I can get an outline.
Yes. Here, what happens? Here many applications are hosted. So these are all source end applications. Also destination application. Okay. These applications wish to exchange data to each other. This kind of work orders they will share here. We look at this network diagram. We are going to configure the setups. Okay. Then messaging is enabled between the applications.
What about documents like that PPT, etc.? If you join the course, you will share them? Or
yeah, we share everything. We share all the material I provide. Red books, okay, required red books, required theory material, documents, and lab materials. Everything we provide. MQ softwares downloading, MQ for Windows downloading, MQ for Linux downloading, VMware downloading, Linux operating system download link, Red Hat Linux 5 download link. Okay, all the required softwares we provide. Okay, it is very much lightweight component. On any host you can install, you can work on that. Okay, there is no issues. One more thing here I need to introduce. MQ predefined objects, MQ predefined commands are consistent between the platforms. Okay, whatever the MQ predefined commands you execute on Windows MQ, the same commands you can execute on Linux MQ, on AIX MQ, on Sun Solaris MQ, on HP Unix MQ. The commands and the predefined objects are consistent between platforms. I will show you some commands here. I will show you some commands. Wait. You are in Queue Manager control area. You are working under MQ server control. Try to execute something here. 1, 2, 3, 4, 5. What it says? Valid MQSC commands are as listed below. Okay. As a WMQ system admin, you work with these commands. They are normal English words. Connect Linux host. Connect the Linux. Let me minimize all this. To work on Linux host virtually, we use client component putty. Just here I login as root. Then let me switch as MQM user. Let me get into this queue manager. Run MQSC followed by queue manager name. Here I try to execute something. What it says? Valid MQSC commands are as listed below, right? We are going to work on distributed systems. We enable messaging between distributed systems, Windows to Linux and Linux to Windows. Okay, we always work at command prompt. Any queries? Yes, please. Any queries from Vijay?
So Madhu, yeah, Madhu, first we are going to install software and then start the classes, right?
We install MQ on Windows first. For 1 week we discuss on Windows. Once if you are comfortable with Windows MQ, then we install VMware Workstation. In that VMware we load Linux operating system. On top of that we install Linux MQ. Okay. Then we enable messaging between Windows to Linux, Linux to Windows.
Perfect.